Hello, in this episode, we'll see how to conduct supervised learning using Keras. The overall process is to load the data and then set the training and test data sets and standardize the data, define the neural network model, compile and fit and evaluate. So the overall process is very similar, except that in actual cross-sectional analysis, you need to have to split the data into what you use to train the neural network and to test the performance, and which was not used in the training process. And oftentimes you have to scale your data to optimize the fitting process. So for this analysis example, we are going to use Boston housing, and you'll have to use Kaggle, Boston house prices. So if you download, you can go here and then advanced regression techniques and download, click download. It will give you a zip file. You can go and here to Boston. So you can download that and unzip it. I have already done this, and how it looks like is here. And where does this come from? The data actually comes from the original source was actually here. So the Boston housing data, the Harrison Rubin field, the hedonic prices and the demand for clean air, it was an early article, and they posted the data points here for Boston housing prices. The variables here are many demographics of the area. So CRIM here, the per capita crime rate, then ZN is the zone for lots for 25,000 square feet and so forth, indicator for Charles River dummy and many things. Eventually, the one that wants to predict is MEDV, the median value of the owner-occupied home in the unit of $1,000. Okay? So using all the other variables, we want to predict what the price here is. Okay. So prepare the file here. By the way, Keras makes it easy. So given that this is a very frequently used benchmark data set, Kaggle allows you to, I'm not going to, but if you just call Keras datasets and Boston housing and load the data, it will actually upload the data. It's automated because many people just use this database a lot for benchmarking purposes. But for us, so here a simple description of what the variables are. First, you have to import the libraries. As usual, we'll use NumPy, Panda for plotting, the matplotlib, and then TensorFlow. We'll use the sequential method. So just the sequential and dense from the Keras is enough that we need to load. And then you need to load the data. And it is Boston. Okay, and it had no missing and all this. I can just store it in a data frame. You need to check. I'm just going to convert it to lowercase letters for the columns. Okay, so column str lower, that's how to convert to lower columns. And then you can check the missing, but there are none. So none of the variables have missings here. The is NA checks it. And then are there any duplicate data? Actually, there are none. So it's a fairly clean, nicely cleaned up data set. And the summary statistics, if you will, for all variables, you can look at it here, how the mean and all this look like. Probably the CHAS, the Charles River indicator, the minimum is 0, largest is 1. It's an indicator variable 0 and 1. Okay. So now it's actually a new part. In actual cross-sectional analysis, you want to have a training data set and test data set out of your full data. And the way you do it is, first you set the X and Y variables. All the columns except the medv, the median value, are the explanatory variables. So df, my data frame, location of the df columns not being medv will be my X. And then the Y variable is, of course, the one that actually the column medv. Okay? So once you have that, there is a function that I provided in already the package, called train test split. It automatically given an X and Y, and I specify how much fraction I want to devote for testing data set. Let's say 30%, 0.3. Okay. Once I call this, it will give out X train, X test, Y train, Y test data. Okay. And you can separately see it. X train is 354 rows, 13 variables, all the explanatory variables. And the Y variable is 354 rows and 1, of course, the median value of housing price. The test data are 152 observations. The X has 13 columns and the Y has 1 column. Okay, and the summary statistics of the X train looks like this. Okay. Oftentimes, when the values are large, like 11 and all this, it's probably not the best thing to run a neural network by itself. So sometimes we normalize it. When you normalize it, meaning I subtract the mean of the data and then divide that difference with the standard deviation. But you want to compute only using the training data. So the mean of the X train and the standard deviation of the X trains are used to scale the X train as well as the X test. You do not want to use the mean of the test data because then you will have a loop ahead bias. Right? Just be careful with that. There are automatic processes for doing it. It's called standard scaler function. So standard scaler, you can call that, but I'm just showing you how to do it. It's not too many lines more, so I'm just going to show it here. And you can check the mean. The means are, now that it's scaled, the X variables are all very close to 0. Okay. The test data are sort of small, but not quite 0 because you're using the subtracting the mean of the training variable. So it's not exactly setting off all the means. And the standard deviations are, for the training data, it's perfectly 1, but for the test data, it's close to 1, but not exactly, but you know, it's kind of there. And the size is 354 by 13. Okay. So now what we did, sequential method, just set up the design the neural network. We have 13 input nodes. First, the hidden layer will set into 128 node hidden layer. And then hidden layer 2, we want to have 64 nodes. And then we'll send it to output 1 node, isn't it? So 1, I don't have a choice. 13, I don't have a choice. It's dictated by the data. The middle, how many middle layer I want, how many nodes I want. I have a controller, I can do it. The activation in the middle layer, typically I use a relu. It gives better convergence. The output, I have to be careful. I'm not going to use a sigmoid because housing prices are not between 0 and 1. Okay, so I'm gonna use a linear activation function. I'm just gonna put output what the neural network predicts. The optimization, the optimizer is Adam optimizer. Alternatively, I could have used stochastic gradient descent. The losses, mean square error. Here, I'm not using binary cross entropy because the output is not a 0-1 variable, it's prices. So mean square error is a better loss to measure. And the metrics I'm gonna show is a mean absolute error. So I can do it. The model summary shows the neural network structure, 128, 64, and then 1, okay? And how many parameters are involved. So let's fit it. So I'm gonna use 100 epochs, and I'm having a 5% for validation inside it. It runs fairly fast with the loss and all the MAE. Now that I have it, I can plot it. So here is probably what you just want to copy these lines of codes in the future if you need to. It shows the training history of the loss and validation losses. Okay. By the way, when I trained it after fitted, I actually had something called history. I saved all the training loss history in a history variable. Rather than just calling model fit, I have the model fit equal to history. So the history contains all the history of how it trained. So in the history of the losses and the validation losses, I can plot it. It will give me a plot of during the 100 epoch training process, how the losses drop down. So it quickly drops down close to 0. And I can also do this now mean absolute error. And then what I can do is to test the data. So MSE test data, MAE test data for the model evaluate. I'm giving you the X test and Y test. So it puts the X test in my model, gives a prediction, and then see how the error comes out to be. And you can see that here, the mean absolute error on the test data is actually not that large, all right? So this is showing how to do a cross-sectional analysis. You can, of course, output a lot more other things. You can look up in Google about this Keras cross-sectional analysis, and it will help you also with a lot more features. But what I'm showing you here are sort of the basic things that people do when they do a cross-sectional analysis for supervised learning. Thank you for watching the video.